So today we're going to talk about something really, really cool, using gravity to power our future. That's right, the same force that, keeps us all from floating off into space could be the key to storing massive amounts of energy for our power grids. Now, the idea itself isn't totally new. We've been doing it for a century with pumped hydro, but a couple of companies are taking this in a pretty radical new direction. Okay, let's get into it.
So, how can this actually work? Well, imagine lifting something heavy. By doing that, you've just stored potential energy in it. Now, if you let it fall in a really controlled way, you can convert that energy back into electricity. It sounds like something straight out of a high school physics class, right? But the real question is, can we actually scale this thing up to power entire cities?
Okay, so the basic idea is actually super simple. When there's extra cheap power on the grid, let's say from solar panels on a super sunny afternoon, you use that extra juice to hoist up a massive weight. Then, later, when you need that power back, you just let the weight come down, and its fall spins a generator, pushing electricity right back to the grid. It's basically a mechanical battery, but instead of using water, you're using a giant solid block. The physics are simple, the real challenge is the engineering.
And that brings us to our first player in this game, a Swiss-based company called Energy Vault. Their initial idea was, well, let's just say it was impossible to ignore. A giant, towering structure that was meant to turn this simple physics concept into a huge, grid-scale reality.
So their first big idea was, and I'm not kidding, basically a giant game of Jenga played by robots. Picture this, a huge freestanding tower with a bunch of cranes on top, constantly lifting and stocking these enormous 30-ton concrete blocks to store energy, and then unstocking them to release it. It was a really bold concept that for sure got a lot of attention. But, when you have a big idea like that, it's going to get a lot of eyeballs on it. And with that came some pretty tough critical questions from engineers, like how in the world do you keep a 30-ton block from swinging around like a pendulum on a windy day? What about all those blocks at the bottom of the stack? I mean, they have zero potential energy if they can't fall any further. And think about the massive stress on the tower itself. These were some serious issues to figure out. So faced with all these pretty serious engineering hurdles, Energy Vault did what a lot of companies do. They pivoted. They moved away from that open-air tower idea and evolved their design into something they now call the Energy Vault Resiliency Center, or EVRC. The bottom line is, they took the whole operation indoors. And this new vision is, well, it's huge. We're talking about a warehouse the size of a football stadium. Inside, this incredibly complex computer-controlled network of pulleys would be shuffling those 30-ton blocks around. But here's the really important part, you guys. This is still a concept. What we're looking at is a computer rendering, not a facility that has actually been built yet. Okay, now let's switch gears and talk about our second contender, Gravitricity. They're an Edinburgh-based company with a completely different philosophy. In fact, their approach is the complete opposite. Instead of building up, they're digging down. And really, this quote from them just says it all. Their core belief is, why would you build this massive, expensive steel structure to support all that weight when you've got the entire planet to use for free? I mean, it's exactly what pumped hydro does. Why build a frame when you have the Earth? Their whole idea is to repurpose old, decommissioned mine shafts. They lower these enormous weights, and we're talking about weights of up to 500 tons each. I mean, that's just huge, deep into these existing shafts. The winches that lower the weights, they double as generators, producing electricity on the way down. It's so clever because it uses the Earth for support and gives a new life to these old industrial sites. Okay, so you might be thinking, wait a minute, I've seen pictures of their test rig, and it was a steel tower above ground. What's the deal? And that's a great question. It looks a little counterintuitive, right? But it was a really pragmatic choice for testing. Building that rig above ground made it way easier for their engineers to access everything, see how fast the system could respond, and most importantly, prove that their computer simulations were right before taking that much bigger, more expensive step of building the real deal underground. And what they learned from that testing, well, it's pretty impressive. Their core components are designed to last for over 50 years. The cables can handle 75,000 cycles. For perspective, that's about 10 times what a typical grid-scale battery can manage. On top of all that, the system is incredibly versatile. It can provide that super fast, instant response power the grid needs for balancing, and it can also provide long-duration storage for up to 8 hours. All right, so there you have it. Two totally different visions for the future of gravity storage. You've got one that builds a massive man-made structure up toward the sky, and another that goes deep into the Earth. Let's put them head to head.
So let's break this down head to head. The fundamental difference is pretty clear. Energy Vault is proposing a modular, man-made building for stacking blocks. The big advantage there is that, in theory, you could build it almost anywhere. Gravitricity, on the other hand, uses existing mine shafts, so it's relying on the Earth itself for support. And here's the really crucial difference right now. Energy Vault's design is a computer concept, while Gravitricity has already built and validated a physical prototype.
But at the end of the day, a huge part of this comes down to one thing: money. Is it actually affordable? This chart looks at what's called the levelized cost of storage. Basically, it's the all-in cost for every bit of energy you store and get back over the system's entire life. An independent analysis found that for storage up to 6 hours, Gravitricity's system could be cost-competitive with lithium-ion batteries. And a big reason for that is durability. Unlike batteries, which degrade over time, these mechanical parts can just keep on working for decades, which really brings down that long-term cost.
So, where do we go from here?
Because, getting from a cool idea to a real working power plant it's incredibly difficult. No amount of slick computer renderings can speed up the basic laws of physics and the hard work of engineering. And this is where Gravitricity has laid out a really clear step-by-step plan. They're in the middle of an 18-month engineering design phase for their first full-scale project right now. After that, it's another 18 months to actually build it. That puts their first commercial project on track to be up and running sometime in 2025 or 2026. And after that, they plan to roll out more projects even faster.
And that really leaves us with the big question here. As we search for new ways to store energy and power our world, we have these two very different approaches to gravity. So will the future of our grid be supported by massive structures we build reaching for the sky? Or will it be by harnessing the immense foundational power of the Earth that's already right here, just beneath our feet? It's a fascinating question, and one we're definitely going to see answered in the next few years.